Well, good morning, everybody. It's 10 o'clock. We'll go ahead and get started. My name is Luis Gutierrez, sales engineer here at Long. Welcome to our June 27th edition of the Coffee Break. Today, we have the honor of having Mr. David Milligan from Innovent, a national sales manager, and he'll be discussing altitude pools, natatorium design. Welcome, David. Thank you for joining us, and I'll let you take it away from here.
Thank you very much. Glad to be here. Talk about one of my favorite topics is natatorium design, pool designs, and really we're focusing on indoor pool spaces. And I always like to bring up the differences between a indoor pool space and basically maybe an office space where there's comfort cooling. There's several different characteristics between the two. And I'm just going to point out a couple main ones. First off is space construction. Generally, these are very large spaces. They also have a lot of small microclimate potentials inside of it. You could have one part of the indoor pool space that is just a lap pool, very minimal amount of splashing. But you can have another area that might have a leisure pool or a rec pool that has some kid features, whether they're dump buckets, mushrooms, small little water slides. Those all crank out a little bit more, evaporate, so you could have these different climate zones or microzones right within that same space. More often than not, these pool spaces are at a much higher temperature. Typically, they're between 82 and 86 degrees. That means we're in a heating mode more times out of the year than we are for an office space, which is generally held around 72 to 75 degrees. Another big difference is the humidity. Because of all this splashing and water in the space that's evaporating, our humidity is going to be a little bit higher than typical. We try to maintain 60% RH in these spaces. And generally that is a good spot. ASHRAE recommends between 50 and 60. So we always try to go with that 60%. And another big concern with these spaces is because we have this evaporation going on, we get a lot of these airborne chemicals, the chlorines that they use to disinfect the pool. Once they do their job, they off gas as a chloramine, and it's that chloramine that we smell, that when we're in the pool spaces, causes our eyes to turn nice and red. That's also the chemical that, if starts condensing on structure or on other steel, can really start corroding the steel in the pool space. So it's that chemical we really want to get rid of also. So a lot of design challenges that we face in these, and I'm going to break these into three main areas, is dehumidification. We want to make sure that we're controlling that humidity in the pool space. We don't want to start causing condensation anywhere in the structure, because that could then start corrosion. We also want to make sure we have very good ventilation coming into the space. We want to make sure that it's a healthy space for both the swimmers and the lifeguards and spectators that might be in there. Last, we want to make sure that it is a very simple type of a control system. We want to make sure that we're maintaining space temperature, we're maintaining space humidity, and last, we want to make sure that we're maintaining the right pressure in that pool space. We want to maintain a slight negative in that area, because we want to make sure that we're pulling air in and not taking all those chloramines and humidity and pushing it out to other spots in the building that you can start smelling, or worse yet, start corroding other areas in the building. So those are the three main areas that we are really concerned with when we're designing these pool spaces. And up first, I'm going to talk a little bit about the dehumidification methodologies that are really out on the marketplace right now. There are two main ones. There's a mechanical dehumidifier, and then there's an outdoor air dehumidifier. Like it says, you're really utilizing outdoor air to do all the dehumidification. Up first, the mechanical dehumidifiers. Basically, they're taking the return air, bringing it through an evaporator coil where they are reducing that temperature from 86 down to something much lower, condensing that air to get rid of that RH from 60% and dropping that down. They're taking all that heat that they capture, and plus the heat of the compressors, and putting it into either a pool water heater or sending it to other spots to maybe provide reheat, or just like on an air-cooled condenser to leave the system and go to the atmosphere. The other methodology here is our outdoor air dehumidification. And like it says, we're utilizing dry outdoor air to do all the dehumidifying that's required for that pool space. And the beauty of being in the Denver area is your air is nice and dry all year round. So you really don't need to do any mechanical dehumidifying to handle most of these pool spaces. It can all be dealt with utilizing your outdoor air. We might need to put some type of compressorized system in there to handle a cooling load to maintain space temperature, really depending on what type of sensible loads you have on the space. But generally, we don't need compressors to run all year round to do the dehumidification. Up next is our ventilation, and this basically is how much outdoor air is required for a pool space. And for this, we're going to really turn to ASHRAE for guidance. We're going to take a look at ASHRAE 62.1. There's a formula within there that helps us determine how much outdoor air as a minimum is required. And that's basically taking the full square foot of your space, deck and pool, timesing it by 0.48 and coming up with the value for the minimum outdoor air. If you have spectators, you add another 7.5 CFM per spectator to get what you need for a minimum. But right within the ASHRAE Applications Handbook, if you take a look at that publication, it states right within there that the minimum amount of outdoor air that's used in standard 62.1 might not be enough outdoor air for a high occupancy pool. And my point on this is, what pool space are we designing or trying to provide ventilation to isn't being considered a high occupancy pool. Whether they're a YMCA, a rec center, or a high school pool, we want people to come to that, and that's really how these facilities generate their money. So we want to make sure that they have a high occupancy there. So there's a little bit of a gap between what ASHRAE Standard 62 is saying, and then again what the application handbook states. So that leads to the question is how much outdoor air is good for indoor air quality? And Innovent's been doing pool units since the early 80s. And what we take a look at is we're going to take a look at that ASHRAE calculation to see what it says for outdoor air, or we're going to say 25% of the supply air based on 6 air changes for your pool space. Generally, when we go with the 25%, that gives us 50% more outdoor air than what the ASHRAE 62.1 recommends. And what does that mean? You know, there's a lot of nice pros. It gives a lot more ventilation into the pool space. It helps remove those chloramines. It gives us a much better, healthier space, gives a much lower cost of operation because I'm not running compressors, especially in these environments that have really dry outdoor air. Say in Denver, I'm not running compressors to do any dehumidification. I'm using that outdoor air and really bringing in a lot of nice fresh air to help ventilate that pool space. Plus, when you pair that up with some type of energy recovery system, whether it's a plate heat exchanger, even if it's a runaround coil, a heat pipe, or some type of glycol loop, you're helping to reduce the impact that bringing in more outdoor air does on the total system cost for operation. And that's some of the cons that some people will try to bring up is, hey, you're bringing in more outdoor air, especially in the wintertime, you're going to have to heat a lot more, but having some type of energy recovery device in the system really helps mitigate some of those concerns. Also, some items, some people will say that, hey, in the middle of winter time, I could drop below 40% on the RH. Yeah, you know, you could have that, but there are ways to reduce that amount of outdoor air coming in to help reduce some of that concerns. So one of the other items that we take a look at is, okay, we're at 25% minimum, but is there a benefit for increasing the amount of outdoor air? And what we see is as we increase that amount of outdoor air from maybe 25% up to, we'll say 50% outdoor air, we see the ability to bring in, or that outdoor air helping to dehumidify that pool space for about 2 to 3 months longer. So we don't have to run compressors that much more. So that really helps, with that operating cost. Now I'm not running compressors maybe 9 months out of the year. Definitely in the Denver area, it's only going to be there for sensible temperature control only. But I'm basically reducing the amount of runtime on the compressors. And that's just it with the mechanical dehumidifiers. They're running their compressors 24/7, 365 days out of the year because they want to dehumidify, capture that energy, and try to put it back into their pool water heater. And what we see, even with that pool water heater that they're taking credits for, that our operating cost is a much better position than the mechanical dehumidifiers, especially if we're taking a look at these dry climates, altitude type of applications that Denver has. We can almost save up to 50% on the operating cost of a unit compared to a mechanical dehumidifier. Even when we get down into those very warm, humid climates of Dallas and Atlanta, we have an operating cost advantage. Plus, we also are bringing in a lot more outdoor air than what they typically bring in, the mechanical dehumidifiers typically bring in. So we have a much better indoor air quality than what they can provide. So that's a nice advantage for having these type of units with the ventilation of outdoor air. Lastly, we were talking about controls. Control is a very important part here. And with ours, we have a lot of sequences that we do utilize on a lot of our pool units. Our first thing is we're trying to maintain the humidity. So we're going to make sure we're operating our outdoor air and return air dampers to maintain the dew point in the space. If and only if we reach our maximum amount of outdoor air, then and only then do we turn on our compressors to do dehumidifying. Last, we're trying to also provide air temperature control. So that's another function that unit has to provide. And then last, we need to make sure that we're maintaining space pressure. We want that space under a slight negative, so we're pulling air from other spaces and ambient into that pool space and not really pushing that air out into other areas. So you have to make sure that your controls have that, and that's exactly what our system has, is really easy control sequences, really ease of operability. And we provide this lovely UI home screen that you can go into, connect your computer to, and really get to see every point that's going on in that system. So if we go back and take a look at, hey, we had these design challenges, controlling humidity. Yep, we're taking care of that. We're promoting a healthy space by bringing in a lot more outdoor air than the mechanical dehumidifiers. We're controlling space pressure. We're helping the water chemistry by removing those chloramines that are in the space and allowing other chloramines to come out of the water. So it's a very good system and obviously we're hitting all the main design challenge points. And just to reiterate, we had a system here at the University of Minnesota, beautiful swimming area where they have large competitions. They were actually banned by the NCAA from holding any meets because the air quality was so bad in the pool space. They had a couple of mechanical dehumidifiers that were not up to task. So they looked to replace equipment. We provided 2 units for pool space control to control the humidity. And then we provided 2 units to handle the spectator loads. They had potential up to 2,000, 3,000 spectators on the sides there. And those spectator units just help maintain a nice, comfortable area for the spectators. One area you can go to for more information, obviously, you can go to the Innovent website at innoventair.com. You're going to find design guides. You'll see some case studies. One example is that University of Minnesota case study. One thing I forgot to point out is they did a before and after reading of the chloramine levels in the pool space. They saw a 70% reduction in the amount of chloramines that are in that pool space. So that just goes to show what the advantages are bringing in outdoor air and really utilizing a lot of outdoor air for dehumidifying those pool spaces. Also on there, we have some application videos, so you can take a look and at different application videos, plus links to other sites within the industry on the pool market. So hopefully that answers a lot of quick questions for you. I'm going to turn it back over to us, It's all yours.
Thank you, David. Very, very good information. Appreciate you taking the time to present to us today. And thank you for everybody online that participated. And then next week, we will not be having a coffee break in observance of July 4th, but the following week, which will be the 11th, if I got my calendar correct, tune in for Travis Cowan, who will be presenting on innovative cooling technology and industry leading efficiency with tower tech cooling towers. So should be a good topic, and thank you for joining in and taking the time today. Have a great day.